Welcome, and thank you for joining us today. We're going to be speaking about how to build event-driven applications on Google Cloud using Eventarc. My name is Bryan Zimmerman, Product Manager at Google Cloud, focusing on Eventarc.
And my name is Mete. I'm a developer advocate at Google Cloud.
Before getting into the details, let's look at our orchestration suite of products at a high level. Today, as we're talking about building event-driven applications, Eventarc is the product that helps you accomplish this easily. Along with workflows, tasks, and scheduler, Eventarc is part of a suite of products that are fully managed, flexible, and enterprise-ready to help you accomplish all of your orchestration needs. Eventarc connects to over 60 GCP services through its integration with Cloud Audit Logs. In addition, our integration with PubSub as a source allows you to use Eventarc for events raised from your own application. As far as targets, we currently support Cloud Run in GA and Cloud Run for Anthos and functions in preview. Our other products support even more targets through HTTP execution. Together, these fully managed and flexible products help developers connect the cloud with less code. In our demo today, you will see many of these products in action, specifically Eventarc, workflows, Cloud Run, and Cloud Functions. So what do we mean by event-driven architecture? First, let's talk about the modern application. Here's an example of a simple application with a complex web of service teams working together towards a common goal. This application is somewhat complicated, with interactions and dependencies that can become a drag on velocity. But in reality, today your application is more likely to look like this: an extremely complex web of point-to-point interactions, creating a significant number of dependencies and points of failure. As applications expand horizontally, connections become even more complex and difficult to understand. While microservice patterns provide a great deal of advantages, they also come with a great deal of complexity. By contrast, event-driven architecture produces a solution for this problem. It provides the ability to reduce dependencies and complexity in your application while still allowing the creation of more and more microservices. Event-driven architecture allows true separation of concern. A producer need not know how an event will be consumed or take on any dependency from a downstream service. Similarly, the consumer only needs to know that the event will be raised and understand how to utilize it, none of the details of the upstream service. With this loosely coupled approach, we eliminate hard dependencies between services and eliminate that drag on velocity. In a traditional application, you can only scale one way, vertically. With event-driven architecture, a developer is easily able to scale an application as performance needs increase. Furthermore, imagine a scenario where you're adding a new service to an existing application. In a point-to-point signaling model, upstream services must be updated in order to signal the downstream services. However, in an event-driven pattern, users are easily able to add a new service from existing events without updating the upstream application at all. This helps to eliminate that spider web of concerns and point-to-point interactions substantially. Eventarc is Google's solution to this problem. It is a managed eventing system that makes building event-driven serverless applications easy. Simply select the Google Cloud service or PubSub topic you're interested in as a source, define the filter parameters, and choose the target you wish to invoke. We do use PubSub in the background as a transport layer to benefit from its superior reliability and observability. But we take care of all the details of setup. Simply create that trigger and we'll take care of the event ingress, the filtering, and the delivery of events to your desired target. Lastly, we use the CNCF standard cloud events format. And because of this, it's easy to understand and unmarshal the details of your events in order to more intelligently drive application behavior. Now I'd like to share an important customer story from one of our customers, Vivint. Vivint is an exciting IoT company. They currently power the smart home for over 1.8 million customers. Their portfolio of devices is impressive, offering smart home bundles that cover everything from cameras to locks to important sensors such as flood sensors. As these devices are important for ensuring your home is running smoothly and safely, latency and reliability of the back-end system is extremely important for creating the right customer experience. Let's talk a bit about the challenge they were facing. In 2020, Vivint was presented with an exciting business opportunity. They intended to offer a standalone doorbell camera outside of their smart home bundle. This was an interesting technical challenge. Their core system, you see, was built around the concept of bundles, so this standalone offering was a significant departure from that model. Lastly, time to market really mattered. There was a limited window they had in which to make this happen in order to address this fast-moving market segment. Here's what they built. By leveraging events and serverless technology, they were able to separate the components needed to run the camera application from the core platform without having to rewrite everything, and without adding any risk or instability to the user experience of either the new application or their core offering. Let's examine in detail the architecture used for their use case, or one of their use cases specifically, an image processing pipeline for their camera application. Images were loaded from the camera to a GCS bucket. This invoked a cloud function or Cloud Run for Anthos service, which analyzed the images using the computer vision API in order to categorize and annotate appropriately. The results were updated in a BigQuery dataset for use later. And the front-end platform was signaled via an integration with PubSub. Firebase FCM was used in order to send notifications to the mobile app, and their core platform received the event for historical reasons and tracking. The result? Eventarc and GCP serverless technology allowed them to accelerate time to value and time to market. Not only did these products help solve their problem, but did so in a way that would scale, and by achieving separation of concern without risking their core technology. To dig into some of the secondary benefits, this provided a number of things that were really interesting to them. First, it decreased time to market, as I mentioned. The back-end system was developed and ready to go earlier than expected. They were also able to implement continuous deployment. They deployed new code after every 2-week sprint. This is an improvement over the previous quarterly OTA updates. By using event processing in the same location, they were also able to, in the same location as the notification service, they were also able to decrease latency by 78%. And finally, built entirely on managed serverless and orchestration products, the new solution was scalable even in the most successful scenarios. Vivint didn't have to worry about scalability out of the gate, as they were able to rest assured in the confidence of Google Cloud's ability to scale. Hopefully, Vivint's story helps exemplify how Eventarc and Google Cloud can help accelerate time to value for your organization. To help understand how this can work for you in the real world, Mete has created a demo of a similar image processing pipeline. So with this said, I will hand things over to Mete.
Thanks, Bryan. I'll show you a simplified image processing pipeline. In this pipeline, users drop images in a cloud storage bucket. These images will be processed by a chain of Cloud Run and Cloud Function services. We use Eventarc to trigger the pipeline via Cloud Run and workflows to orchestrate the services that process the images. Let's have a look. Okay, before running the demo, let's look at the architecture diagram. First, we have end users saving some images to an input bucket. Once the image is saved, this generates an event, and this event goes to a filtered Cloud Run service. Now, this event is routed using Eventarc's cloud storage trigger. Now, the filter service will receive the image, and it will use Vision API to determine if it's a safe image or not. If the image is saved, then the filter starts a workflow execution. This workflow execution, called image processing, will call a number of cloud functions. The first cloud function is called labeler. Labeler will receive the image, and again, it will use Vision API to extract the labels out of the image, and it will save them to an output bucket. Then workflows will call a resizer cloud function. This will take the image and resize it into 400 by 400 and save it to the output bucket as well. And then there will be another function called watermarker that will receive the labels from the first function, and it will also receive the resize image, and it will add a watermark using the labels on the resize image, and then it will save it to the output bucket. As you can see, these are three separate functions, but they're orchestrated together using workflows. So how do you set something like this? We'll take a look. But before I show you the code and the setup, all of the code is on GitHub, and all the instructions are on GitHub, so feel free to check it out yourself as well. Now, first, let's take a look at what we need to do. So this is the GitHub page. And before you begin, you need to set up the project ID. You need to enable the APIs that we need with Eventarc and workflows and others. Then we need to pick a region, and we need to set our Cloud Run region and our Eventarc location to that region. And then we need to configure some service accounts because we're going to use them in Eventarc triggers. So we want to make sure that we have a service account with Eventarc event receiver role. And we also need a PubSub publisher role for the cloud storage trigger. And we also want to make sure that our PubSub service account has the service account token creator role. Now, once we have all of those, and I already said all of this, we need to create storage buckets for our images. So we create one bucket for the input images and another bucket for output images. So this is where the images will be saved by the users, and this is where the processing will happen, and the output images will be saved as well. All right, then we can start deploying our services. If you remember, we had three cloud functions: watermarker, resizer, and labeler, that are orchestrated together in a workflow. So let's look at watermarker first. Watermarker, it's a C# function, but it can be in any language. And to look at the code quickly, what it does is that first we read the bucket name as an environment variable. This is the output bucket where we're going to save the image once we process it. Then we receive HTTP requests in this method. And from the HTTP request, we extract a couple of things. First, we extract the bucket and the file information so we can download the image. And then we also extract the labels that will be passed in by workflows. And we're going to use these labels to add a watermark. Then we download the image from the bucket. Then in this piece of code, we use an image processing library to use the labels and add a watermark on top of the image. And then finally, we save the image with the watermarks to the output bucket. All right. Now, to deploy this service, we just use gcloud deploy. We specify the runtime as .NET 3. We make sure that this is an HTTP triggered function. And we also pass in the environment variable for the bucket so that the function knows how to save where to save the image. So once this is deployed, we can move on to resizer. Resizer is very similar to the previous watermarker, but instead of adding a watermark, it resizes, and we deploy it pretty much the same way. You can check out the code if you like. And then labeler is again very similar function. Instead of resizing the image, it extracts the labels out of the image, and it uses Vision API to do that. So if we take a look at the code quickly, you can see that the labeler will receive the bucket and file information. Then it will call this extract labels async method with the storage URL of the image. And if you look at this method, it basically uses the Vision API client and calls the detect labels async to extract the labels. Then we order the labels by score, and we return them in a list that we use. So once we return the labels, what we do is that we first save these labels in a text file to the output bucket. And then we also extract the top 3 of these labels and return them as HTTP response data. And we're going to use this from workflows as well. Okay, so that's labeler. And now we need to put these into an orchestration. And we do that with workflows. And to define the workflow, we create a workflow.yaml file, and then we'll define what happens in that YAML file. So let's take a look at that quickly here. So in workflow YAML file, first it receives some arguments. This will be coming from our Cloud Run service that I'm going to show you next. And in these arguments, we have the information about the bucket and the file. And we also pass in the URLs of our services because we don't want to hard code these URLs of these functions. So instead, we pass them in as arguments. Then we have our steps. In the first steps, we log our bucket and file information just to make sure that we are on the right track. Then in the label step, we make a call to the labeler URL, which is the URL of the labeler function. And we pass in the bucket and the file, and then this calls the labeler function, and then we get the response from the function and save it to a label response variable. Then we do the same with resize step. So in the resize step, we just call the resizer and capture the response in resize response. Then in watermark step, we call the watermarker, but we pass in the bucket and file information from the resize step. This is because we want to add the watermark for the resize image, right? So because of that, we pass in the resized images bucket and file information. And we also pass in the labels from the label response, because these are the labels that we extracted from the labeler function. So we are passing them in as well. And the watermarker will use those labels to add the watermark. And then in the final step, we return the HTTP status code from all the steps just to make sure that our workflow completed successfully. Okay, so that's workflow, and to deploy our workflow, all we need to do is just use gcloud workflows deploy. So let's just copy this and go back here and deploy our workflow. So this will look at our workflow.yaml, and now it's deploying our workflow, which is very quick as you can see. Great. Now the next step is the filter function. So if you go back to our architecture diagram, we deployed our functions, we deployed our workflows. Now we need to deploy the filter Cloud Run service, and we need to make sure that it's connected to cloud storage events using a cloud storage trigger. Now to deploy the filter, this is a Cloud Run service, so we need a Docker file, and we need to build and push the image. So that's what we are doing here. And then we also deploy the Cloud Run service using gcloud run deploy. And point to our image and pass in some environment variables. These variables like the project ID, region, workflow name, this is the information needed for the workflow. But we are also passing in the URLs or our functions, the labeler URL, the resizer URL. That way we don't need to hard code them in our workflow. Now I already did this, but now we need to connect Cloud Run service to cloud storage events. And we do that with triggers in Eventarc. So we create a trigger name, and then we just create a trigger with this command. Here we are saying that this trigger connects this Cloud Run service in this region, and it's filtering these events. These events, as you can see, it's the cloud storage object finalize event. This is the event that gets triggered when you save a file, and we're also filtering on the bucket, right? So let's copy this as well and go back here and create our trigger. So this will create the Eventarc trigger. And now everything is pretty much set. We have our workflow, we have our Cloud Run, we have our trigger. So now to test, we need to drop an image and see what happens. So let's make sure that our trigger is created. Yeah, it's created. And if I do gcloud Eventarc triggers list, we can see that the trigger is up and running. Now to test this out, let's go to our cloud storage bucket, and you can see that I have an input bucket. So let's upload a couple of pictures here. So I will upload one picture of myself, and then I will upload another beach kind of picture. So let's upload these. And now this starts up the whole chain. And if we go to the output bucket, we should start seeing some images. So now I will wait a little bit. So you can see that we have some labels for the first picture. So if you click on the labels and look at the actual file, these are the labels that were extracted from my picture. Now the next one we see is the picture that's resized. This is the 400 to 400 picture, so it's resized to 400 to 400. And finally, the third picture is the resized image with the watermark. And the watermark is just the top 3 labels from the image. And just to show the other image as well, if you look at the beach, you see that it has watercolor and sky as the watermark. So this concludes the demo. I hope you enjoyed it. Thanks very much.
Thank you, Mete. It is great to see our products work together to help customers connect the cloud, with less code, of course. Today, we've discussed what we have to offer in our orchestration and serverless products, how our customer Vivint has used this to accelerate time to value, and even shown a demo that you can try yourself via the GitHub link that Mete had provided to gain experience with the concepts. To learn even more, there are several other sessions that can teach you about other related serverless technology. And of course, please visit us at cloud.google.com. Thank you again for spending us time today. I hope you enjoyed it as much as we have.